We have discussed the introduction of doubly linked list, what is doubly linked list, and how to create a doubly linked list, as well as how to display the content of a doubly linked list. I'll provide you the link of those videos in the side button. You can check out there. Before going to this video, you must check out those videos, right? See, in the previous video, we have created a doubly linked list, right? Like this. One head pointer is there. This is the node. Each node is having two pointers. One is pointing to the next node and another pointer, the previous pointer, is pointing to the previous node, right? It means this pointer is going to contain address of the next node and this pointer is going to contain address of the previous node, right? And this is what the data part, three parts are there basically, right? We have already discussed how to represent this node when you are going to write down a C program, right? And see, in that case we haven't maintained a tail pointer. In this doubly linked list, it is very useful to maintain a tail pointer. Why so? That thing also we will discuss. Now, what is a tail pointer, or you can say a last pointer? See, this head pointer is going to contain the address of the first node, right? Or you can say the head node. So the tail pointer is containing the address of the last node, like this. So in this case, we have a pointer to the first node of the list also and to the last node of the list also. Now, what is the use of this tail pointer? Why we are going to maintain this pointer? See, when you are going to insert any node in the last, suppose I want to insert at end and I am not maintaining this tail pointer, right? In that case, what we will do? We cannot directly insert here. We have to traverse the list till end, right? Because sequential access is possible and we have the information. What you have? We have just this head pointer. We just have the address of the first node, right? That is why you have to traverse the list till end. After reaching till this end, now you can insert here, right? If the tail pointer is not there. And if you maintain, while creating the list, if you maintain the tail pointer, in that case, you don't need to traverse the list till here. Why so? Directly you can insert one node here, because we can access this node using this tail pointer, right? We have the address of this last node. So simply you can update these links, right? How we are going to update these links, that also we are going to discuss when we will discuss this function insert at end, right? So in this case, the insertion in doubly linked list at end will take time order of 1. If you maintain this tail pointer. If you don't maintain this tail pointer, in that case you have to traverse the complete list. It means it will be order of n. And same with deletion. If you want to delete this last node and if you maintain this tail, then time complexity would be order of 1. And if you don't maintain this tail, then the time complexity would be order of n. The delete operation also we will discuss in next video. So these are some advantages of maintaining this tail pointer. But the drawback is what? This is going to take some memory space, right? You have to store this tail pointer. 4 bytes if 32-bit compiler is there and 8 bytes if 64-bit compiler is there. If you don't maintain this, then only if 3 nodes is there, then this node and the head pointer you have to store. But if tail pointer you are maintaining, then you have to store this also. Some memory space would be required to store this tail pointer also, and you have to maintain this also. If you are going to create a list, in that case you have to maintain this tail pointer. At starting, if list is having only one node, then head is also 100, tail is also 100. If you have inserted second node, then head is 100 but tail is now 200. If you have inserted this node, then tail becomes 250. So you have to maintain the value of this tail pointer also, right? Now, we have already discussed how to create a linked list, but in that case we haven't maintained this tail pointer. If you are going to maintain this tail pointer, then how you are going to create the doubly linked list? I'm quickly write down the code for that thing. This is what we have declared we have defined our own data type, that is struct node. For this node, you can say the data type of this node, 3 parts are there. One is data part and 2 are pointers, and these are pointers to node. That is why here data type is struct node. So here we are maintaining what? 2 pointers, head and tail. So we are going to declare 2 pointers, struct node asterisk, one is head and one is tail. right? These pointers are containing address of, see head is containing address of this node, right? So here that is why I am writing, we are writing the address of those thing or that variable whose address this pointer is going to store. So that is why here I am writing struct node, because data type of this node is what? Struct node. Now how we are going to create the list? We are going to define a function, you can say a create doubly linked list, right? So first of all we are going to create a node, right? First of all we are going to create these type of nodes so that we can store these values and these pointers. And memory, how the memory is to be allocated? Dynamic memory allocation, that we have already discussed many times. So I am going to write down that thing here, right? First of all what you will do, you will declare a pointer struct node type, and this is how you can assign the memory dynamically to this new node. See this syntax we have already discussed many times, right? Malloc is the function for dynamic memory allocation. How much size you want, size for this node, right? So here you write size of the data type is struct node, and malloc is going to return a pointer to the starting address of the allocated space, or you can say malloc is going to return a void pointer, and this pointer is what? Pointer to a node. So that is why you have to typecast this pointer. Typecast means you are going to write here struct nodes asterisk, and whatever this will going to return, you are going to store that address in this new node pointer. So after executing this line, one node has been created, means memory has been assigned to that node. So here suppose I am taking that we don't have anything in the list is empty, right? So you can say we have created a node, address suppose is 100, and this new node is a pointer that is going to contain the address of this newly created node. Fine. See this node is having how many bytes? 4 for this, 4 for this, and 4 for this, 12 bytes, and this 100 is what? Address of the first byte, right? So it will, malloc will return this address. So now this address we will store in this new node. Fine, new node is pointing, new node pointer is pointing to this node. At starting we assume that head is equal to 0. It means we don't have anything in the list, and we have just declared this tail pointer also. Fine. Now we are going to insert this newly created node in the list. Now first of all we will ask from the user what data I want to insert here. So this is how you can ask from the user using printf and scanf the data I want to insert here. Enter data, and how you will insert the data here, how you can access this part of this node. This part you cannot directly access this node, you can access this using a pointer. We have one pointer pointing to this node. So new node and this arrow operator, and which part you want to access? Data part. So the data, address of new node and data. So here suppose I have inserted 5, and now here you will insert 0 and 0 first of all. So how you will access this part? The pointer to this node is new node, arrow, and name of this pointer is previous. So is equal to 0, new node, arrow, next is equal to 0. Fine. Now I want to insert this node in this head pointer. Now how you will insert this thing? See first of all, obviously you have to update this head value. Here you will store what? 100. It means after that this is going to point here. Fine. And the next, there is no next node, so this is fine, it will be 0. There is no previous node, so this is also fine, that this would be 0. Now another thing you have to do, we are maintaining this tail pointer also. So in tail also you are going to store this 100. So now tail is also going to point here. Now this is done. Fine. Now how you will write this thing into this code? See, we have just updated head value and tail value. So here what I can write? Head is equal to, tail is equal to, here you will store 100. From where we can get this 100? Address of this is stored in this pointer. So here I can write new node. See, but this is the case when head is equal to 0. It means when list is empty. If suppose we have inserted this data, one node, and I want to insert second node, right? And second node, the address of second node is 200. In that case, the new node will contain 200, right? And if in that case you will do head is equal to tail is equal to new node, means both head and tail are going to point that new node, that is 200 is going to store in head and tail. Now you will lose the reference to this node. So this should not be a case. So before writing this, you will write if condition, if head is equal to 0, in that case only you will write this thing, that is fine. But if head is not 0, then in else part what you will do? Now this is suppose the list. Now I want to insert a second node. In that case what we will do? Now suppose we have created one more node, address is 200. This in this new node now 200 is going to store. We have asked from the user using this new printf and scanf. The data inserted is 6 and here 0 and 0. Now I want to insert this node into this list. So now if head is equal to 0 but head is now 100. So this condition is not true and tail is also 100. So now we are going to enter into else part. Now in else part what you will do? See what you are going to update here, this part also and this part also. Here you will store what? Address of previous node, that is 100. And here you will store address of next node, that is this 200. Fine. After that this link would be established and this link would be established. Plus one more thing, you are going to update this tail also. Now tail is going to point here because this is the last node. So in tail you will store address this, that is 200. So here you will store 200, right? Three things you are going to update now. See, now first of all this was 0. So how you can access this part? Both using head pointer and tail pointer, because before updating this tail pointer is containing 100. So I can write here tail next, tail of next. Here you will store this one, from where you can get 200, from this new node, because new node is containing 200 is equal to new node. So here I can write 200. So this link is established now. Now how you can access this part? The link to this node is pointer to this node is new node. So how you can access this new node, and the name of this part is previous. Here you will store 100, from where you can get 100 using this tail, or you can say using this head. So here I am writing what? Tail, right? I am not writing head because see we cannot move this head. When you will insert the third node, then obviously the address of second node we are going to store here, and tail is containing address of the first node only, right? So here we are going to write here only the tail, because we can move this tail only, we cannot move this head. So now this is containing 100. Now remaining part is you are going to update this tail. Tail is equal to new node. From here we can store here 200. Now tail is pointing to this node, right? Now the same logic you can apply. After this it will ask you, do you want to continue, and if you press 1 then another node would be created and inserted. If you press 0 then no extra node would be created, and only you can call, after that you can call the display function. So that thing we have discussed. How you will write? Here you can write printf, do you want to continue? In scanf you can take the value from the user, and you can write down a while loop here before this line, because if you will insert 1, in that case only new node would be created. So before this line you can write down what? While and choice, right? Choice is a variable you can take in this function only. Int choice is equal to 1, right? And here also printf, do you want to continue? In scanf you can write %d address of choice. This is we have discussed already. Here the main motto is what? How you can maintain this tail pointer. So I hope you got the concept. Now we are going to insert at beginning. How you will write this function? See. So now let us take this case. We have these 3 nodes in the doubly linked list. Head is containing 150 and tail is containing the address of the last node, that is 200. We have created this list by calling the create DLL function. Now I am going to insert a node at the beginning of this list. Fine. So this thing we have already discussed many times. We have created this node, that is new node. We have allocated the memory using the malloc function, dynamic memory allocation, and the address is 500. So this new node pointer we are going to store what? 500. So now this is pointing here. Now we have taken input from the user using this printf and scanf, enter data, and we have user has entered what? The 6, value is 6. So we are going to store the value here in the data part. So how you can access this part? Address of new node, pointer is new node, arrow operator, and name of this part is data. Fine. And here we will store 0 and 0. See, here you can store in the previous pointer. Obviously this is the first, this is going to be the first node. So in the previous node null would be there. So here I can store new node previous is equal to null, but we are going to update this pointer. So if you will not store this new node next is equal to 0, that is also fine. You can only write new node previous is equal to 0. Now how to insert this node into this list, right? We assume that list is not empty, so we are not going to write down that condition if head is equal to null. In that case, head is equal to tail is equal to this new node, only one node is there. I am here assuming that we have 3 node in the list. So how you can write? If you want to write, you can write down that condition also. In else part you can write whatever I am going to write here. So now which link you are going to update? See, you have to update this link first of all. This is going to contain address of this node because this is now the first node, right? So here you will store what? Address of this node, that is 500. Here you will store 500. So how you can store this 500 here? How you can access this part? The pointer to this node is head. Yes, we have a pointer, so we can access all the 3 parts. So here what you can write? Head of previous, this part is previous, is equal to from where I can get this 500, this address. In the new node we have 500, so is equal to new node. So now this is now containing 500, fine. So now this is pointing to this node. Now again you have to set this link. This node should point here. So this node should contain address of the next node, that is 150, right? So here you will store what? 150. How you can access this part? The pointer to this node is new node. So here how you can access new node? This part is next. Name of this pointer is next, is equal to from where I can get 150. Value in head pointer is 150. So is equal to head. Now this is pointing to this node. Now you have to update one more thing, that is head. Now head is containing address of this thing, that is 500. So here you will store 500. So now head is pointing to this node. This is the first node. Now from where you can get this 500? From this new node. Head is equal to new node, right? So this is how you can insert. This is done now. This is how you can insert this. Insert at beginning. No need to change the tail value, right? Now next thing is how you will insert at end. So now the situation is something like this. After inserting at the beginning, we have now 4 nodes in the list, 1, 2, 3 and 4. And now I want to insert a node at the end, right? Here, this node I want to insert here. So I hope you got that this coding would be same. Here I have just updated the name of this function, that is insert at end. Same, we have created this node. Dynamically we have allocated the memory. Address is suppose 400. This 400 would be stored in this new node pointer. We have taken the data from the user. We have here we have put 7 and here we have put 0 and 0. Now how to insert this data here? See, if you don't maintain this tail pointer, suppose tail pointer is not there. Now how you can access this part? Because for inserting this node here, you have to update what? You have to update this part. Here you will store what? 400. Rather than 0, here you will store 400, right? But we cannot access this part because we cannot directly access the structure values, or you can say the variables. You need some pointer pointing to this node, but here we don't have any pointer. That is why if tail pointer is not there, then you have to traverse till here. Like we have discussed in single linked list, using a temp pointer. Temp is pointing here, then here, then here, and then finally temp will reach here. After that, using temp we can access this part. But here, and in that case, the time complexity would be what? Order of n, because you are traversing the complete list. But here we have maintained a tail pointer already, right? So no need to traverse the list. We can access this part directly using the tail pointer, right? So no need to write down the while loop for traversing. Simply you will write. So how you can access this thing? The pointer to this node is tail. So here you can write tail of next. The part of this, the name of this part is next, is equal to from where I can get 400. The address of the next node in the new node pointer is 400. So here I can write new node. So 400 would be stored here now. So now this pointer is pointing to this node. One another thing you have to take care, the previous node of the newly created node. Here you will store what? Previous of the the address of the previous node, that is 200, right? So how you can access this part? The pointer to this node is new node. So here I can write new node and the name of this part is previous is equal to from where I can get 200. tail is containing 200, so here I can write tail. So now this is also pointing to this node. One more thing, see, you have to update this tail also, because here the last node is this one. So tail, in tail you should store address this 400, from where I can get 400, from the new node. So here I can write new node. So now tail is pointing to this node, right? And this is done. See, this tail is equal to new node. Please don't write this here at starting. If you write tail is equal to new node here, means tail is equal to new node, means now tail is containing 400. So this is pointing to this node. So now how you will access this part, because you have already changed the tail value, that is 400. So now we don't have any pointer to this node, so we cannot access this part. So better you change this pointer first, after that update the tail value, right? So now next thing is how you can insert at any specific position. So now we will insert a node at a specific position. Now suppose user enter that I want to insert a node at position 3. It means 1, 2 and 3. After this, here I want to insert, before this and after this, because position 3rd is here only, after these two nodes, right? So now first of all you will check if position is in negative or less than 1, then you can say invalid position. If position is greater than the length of the list, it means also that is invalid position, right? And how to calculate the length of this list using the predefined function, that is length function you can use, and you can calculate the length and store that length into a variable. You can say L, or you can say len, or you can say length variable. And in if condition you can check if position is less than 1 and position is greater than length, it means that is invalid position. In else part, what you will write, that thing here I am going to write. So first of all, in this function what you can write, you can ask from the user, enter the position, and in if statement you can write if position is less than 1 or greater than the length, then you can say invalid position, right? Here in this function you can declare this variable, that is int pos, fine. And suppose if position is 1, it means position 1 means here at starting only you want to insert, fine. So here you can write else if position is equal to 1. In that case you can simply call that function insert at beginning, fine. If you have created all these functions in the same program, or you can write down here, if you are not creating in the same program, then here you can write down that code, insert at beginning. And now in else part, so now if suppose position is 3, user has entered position is 3, means 1, 2 and 3 here after this node and before this node. So you have to create a new node. You have to assign a memory using malloc function. Here we will put 7, here we will put 0 and 0. How we are going to create that, this thing I have already discussed many times, so I am going to write down here simply that thing. So now see, this is how we have created this new node. We have taken the data from the user, that is 7. If you don't insert here 7 and 7, that is also, sorry, 0 and 0, that is also fine, because you have to update this thing also and this pointer also, right? Now how you can insert this thing at position 3? You cannot directly insert here, you have to traverse the list till here. So we are traversing the list till position -1, means till this second node, right? So how you can traverse? Using a while loop. So here what you will write, while, and using a variable, suppose I am taking a variable I less than position -1, right? Position is 3, so 3 minus 1, that is 2. Till here I want to traverse the list. So here you have to declare this I variable also. In this function void insert at position, after this when you are going to declare this pos, here also you can declare int I is equal to 1. You can initialize this also to 1. Suppose I is 1. From here I want to start. So now see, I value is 1 at starting, I value is 1, position is suppose 3. So now how you will traverse this list till here? See, we cannot move this head. So we are going to take another pointer, right? Pointer to a node. So here you have to declare another pointer. Suppose here I can declare struct node, new node, and one more pointer you can say temp. Right, and at starting temp is equal to head. Temp is also pointing to this one, that is 150. So temp is also pointing to this node. So here in else part, after declaring this temp, here what you can write, temp is equal to head, right? Now you can move this temp. Now see, I less than position minus 1, I is 1, position minus 1, that is 2. So 1 is less than this, right? How we will move this thing? First of all, then we will move this temp is equal to here. It means now temp is going to store address of the next node, that is 100. From where we can get this 100? Here we have 100. So here how you can write, temp is equal to temp next, because this part is what? Temp of next. So now temp is containing what? 100, and temp is now pointing to this node, and we will do what? I plus plus, right? Now in I plus plus, now I becomes 2. Now check, 2 less than position minus 1, 2 less than 2, no. So we are not going to move this temp. Now see, we have reached till that position, till position minus 1, because after this only you are going to insert, na, position is 3, 1, 2. So here I want to insert this node, right? Now we have reached till this position. Now we are going to write down the code how to insert this node here. See, I am going to rub this thing. See, this is just you have defined your own data type. This thing you will write outside of these function and outside of the main function, that is globally, because we are accessing this thing in all the functions, right? So now you have to update 4 links. One is this will contain address of the next node. Next is this newly created node, that is 500. One is this will contain address of the previous node, that is 500. One link is this will contain address of the previous node. Now previous of this node is this one, that is 100, and here you will store address of next node, that is 200. So 4 links we are going to update. Now first of all, it is better to maintain, better to update these links. So here what you will store, address of the previous node. Address of the previous node would be 100. So from where I can get this 100? See, the temp value is now 100, right? So simply what you will write, how you can access this part, new node previous. So here what I can write, new node previous is equal to temp. Now we have updated this link. Now update this link. Here you will store address of the next node, that is 200. So now from where I can get this 200? See, here the tail is also containing 200, but always that is not the case. Suppose I have 10 node in the list, so tail will contain address of the last node. So we are not considering this tail now. So from where I can get this 200? From here. Now how you can access this part? Here you will store 200, means it will point to here. So first of all, how you will access this part? See, new node next. So new node next. Now how from 200, how you can access this part? This 200, how you will get this thing? Link of this node is temp. So here you can write temp of next. So now this link has been set. Now you can update this and this. So now here you will store what? Address of next node, that is 500. Here also address of previous node, that is 500. So here also 500 and here also 500. And from where we can get 500? That is new node. But the main point is how you will access this part and this part. See, how you can access this part? Simply pointer to this node is, yes, we have a pointer, that is temp. So how you can write temp of next is equal to new node. So now this link has been set. Now we have 500 here. So this link has been broken and this is now pointing to here, right? Now how you can access this thing? Because we don't have any link to any pointer to this node, right? Just don't consider now the tail pointer. I am considering that suppose I have 10 node in the list and tail is pointing to the last node, right? So now how you can access this part? See, the address of this node is 200, right? How you can reach till 200? See, here we will have 200, right? And how you can access this part? The link of the pointer to this node is new node. So here what you will write? New node, and this part is next. It means we have reached till here, till 200, right? Now at this pointer also we are going to insert, we are going to access this part, means previous part. So here again multiple arrows you can write and the name is this previous, right? Now this is how we can access this part. So here you will store 500, that is the value of this new node, right? So now here 500 is there, this link has been broken, and now this is also pointing to this node. See, I'm not saying that this is the only method you can update these links, right? Maybe after this temp is equal to 100, so you can, at this point only, you can write down, you can take another pointer, that is temp 1, or you can say next node, and at next node you can store this 200. From where you can get 200? Because before updating here we will have 200, right? So in new next node we can write next node is equal to temp of next. So now next node is pointing to this node, right? So you don't have to write these multiple pointers. You have a pointer to this node also, you have a pointer to this node also, right? After this while loop, here you can write, maybe you can say next node is equal to temp of next. Here you have to declare another pointer, that is asterisk new node. In that case you have to take 2 pointers. But see, the concept of 2 pointers basically we use in singly linked list, but here only the single node is having previous node address and next node address. So no need to maintain 2 pointers. Using single pointer only we can insert any node in at any specific position. And one third method is also there to access this part, right? Before updating this 500, here value is 200, right? So how you can access this part? Here you can write temp next, temp, here you can write temp next, and after that again arrow and then previous, and there you can store new node. So third way is also there, right? If you go to this point, then you can write down in the comment box what is the third way, how you will write that thing. So now we will insert a node after any position. So now the function is insert after position. Here the coding would be same except few changes. See, after position means, suppose now position is 3, 1, 2 and 3. So after third, here I want to insert. It's not like at third 1, 2, 3 here I want to insert. In that case here I will insert. Fine. So here I can take that case, suppose position is 2, means 1 and 2. So after this, after 2, here I want to insert. Same thing. See, at starting I am considering this and this 3 nodes, and this is the newly created node, and this node I want to insert here. So now everything would be same. Now what you have to change, same, you will enter the position, you will ask from the user if position is, you will check position is valid or invalid. If invalid, then you will print invalid position. In else part, see, you will not write this case, else if position is equal to 1. If position is 1, means 1. So after this 1, here I want to insert. This is not a case of insert at beginning, right? So this you will not write in this case, after position case. After this invalid, you will write directly else, and now you are going to create a new node like this. You will ask from the user what data he want to insert. So now in while loop, what you will write, the condition, suppose position is 2. Here I am taking the case where position is 2. See, position is 2, this case. After this, here I want to insert, right? So now we are going to traverse the list till this position, right? So here you will insert I less than position only, not position minus 1. Because in that case, if you insert at position is suppose 3, means 1, 2 and 3, here I want to insert. So you have to traverse till 2, means position minus 1. But here after position I want to insert, so you have to traverse till that position, not position minus 1. If position is 2 and you will traverse till position minus 1, then how you can insert this node here, right? So you have to reach till here. So I is less than position now, and this coding would be same. If you don't use this another pointer, simply you can write this thing here. So here I am not going to explain this thing. I recommend you to please practice the operation of these doubly linked list and tell me after writing the same code and this change whether insert after position function is working properly or not. See, I recommend you to please write down this code with your own hand. Please type each and every line. It's not like that copy the code from the net and just simply run the program and yeah, it's done. Because if you want to remember the things for a long amount of time, for a long period of time, then it's better to type each line with your own hand. So here now what about time complexity? See, If you want to insert at beginning, then order of 1. If you want to insert at end, if tail pointer is there, then order of 1, right? If you want to insert at any specific position, then it depends on the, then you can say it is proportional to the number of elements in the list. You can say if you want to insert in the middle, then how many node you have to traverse, n by 2, half node. So in that case it is order of n. So in next video we will discuss how to delete a node from a doubly linked list, right? So I'll see you in the next video. Till then, bye bye, take care.